Alright, so we're talking in Chapter 5 today of Math 1. We're in Lesson 511, which is How Does a Pattern Grow? So what we've been working on so far in this course in the first 4 chapters, mostly the first 3, and then with a bit of statistics trying to get that together with Chapter 4, the other 3 chapters, has been linear functions. And specifically, as we create tables and graphs and equations, we can get lines all the time. In this chapter, we're going to learn about a new family of functions, which is called exponential functions. It's a kind of curve. There are several different kinds of curves. They're not everything that curves is exponential, but this particular type is going to be exponential. And we're going to do that by exploring this task about bunny rabbits. So, Lesson 5.1 says, Question 5.1 says, Multiplying Like Bunnies is the title. In the Book of Mice and Men by John Steinbeck, 2 good friends named Lenny and George dream of raising rabbits and living off their land. What if their dream came true? Suppose Lenny and George start with 2 rabbits, and during the first month those rabbits have 2 babies. Also suppose that every month thereafter each pair of rabbits has 2 babies. So we're going to try to come up with a way to model this. And here are our tasks. First, we're going to try to figure out how many rabbits they have in 1 year. We're going to represent the situation with a written description of the pattern of growth. So we're going to figure out the pattern of how it grows. We're going to draw a diagram and a table. We're going to make some assumptions. We'll come back here and fill in these bullets as we make those assumptions. We're going to compare this to other patterns we've modeled previously. What strategies can help us keep track of the number of rabbits is something we need to keep in mind. What discussion patterns can we see in the growth of the rabbit population? And how can we predict the total number of rabbits after many months have passed? So we're going to do that by working through some problems. We're going to start with our next one, which is to draw a diagram. And keep in mind this bolded pattern words on the side. How can we determine the number of rabbits that will exist at the end of 1 year? Because that's our goal. So can we use what we're doing to find out how many we get? So we are going to start here with this. And so we know they started with 2 rabbits, and then 1 year later there were 2 more for a total of 4 rabbits. 1 month later, excuse me. So that's the first generation. So in our table over here, we have starting value was 2, and then 1 month later we have 4 rabbits. So I'm going to build the table at the same time, just because it helps me keep track. I have a hard time keeping track of what's going on if I don't. And then that next month, each pair of rabbits has 2 more rabbits. That's what it said. So now we are at a total of 8 rabbits, and we're on month 2. And then each pair of rabbits will have 2 more rabbits. So there's going to be 2 coming off this pair, 2 coming off this pair, 2 coming off this pair, 2 coming off this pair. And the color here really helps me know what's going on. This is month 3, and I now have 16 pairs of rabbits. 2, 4, 6, 8, 10, 12, 14, 16 pairs of rabbits. So for me, it's really critical to see the kind of the color that's happening here and what's going on. And I've answered this question and you can see how, before I continue, I've answered the question. After 3 months, there are 16 rabbits. And we'd have to keep going. We'd have to keep doing this pattern several different times. But you can see it's going to get really tricky because from each arrow, so like the blue was my first generation, and it now has 3 arrows now that I've had 3 generations. This black one was my second generation. It has 2 arrows. The red one was my third generation. It has 1 arrow. And if I go one more time, I'm going to have arrows coming off every generation. It's going to get really, really confusing very quickly. So I'm hoping to kind of leave my pattern drawing here. A diagram gets complicated fast in the situation. It's not like the tile patterns, which I can kind of deal with. Or maybe I could do a tile pattern to next generation 4, next generation 8, next generation 16. And so I could draw a tile pattern to help me, whatever makes more sense to you. It's just that idea of what's going on. So what are some of the assumptions we made when we were doing this? And sometimes we make assumptions without realizing we're making them. So in order for the rabbits to keep breeding, every time there's a pair of rabbits, we have to have a male and female rabbit. So that's one of our assumptions, is that there's male and female rabbits each generation. Also, another assumption is that they don't have, that it doesn't matter, they are mating with their siblings. So mate with siblings. Maybe a little weird, but not so weird in the animal kingdom. Really weird for us, obviously. Let's see. And I would say that also that the original pair keeps having babies. And maybe there's some more, but let's kind of keep that in mind. And let's take what we have here and move it to the table on the next page. So month 0, there were 2. Month 1, there were 4. Month 2, there were 8. Month 3, there were 16. So I want you to look at what's happening. So we can probably take this pretty quickly. So from here to here, we added 2. Here to here, we add 4. And then we added 8. Is there another way to think about this that maybe is an addition? Because we keep adding different numbers. What are we going to add next time? Well, we're going to add 16. Because the diagram became too cumbersome and it stops being useful after a while. Table was, for me, better. I'm really glad that the textbook talks about the cumbersome use of a diagram. What else is happening? How do I know the next number is 16? What's happening? And I think if we look at this pattern, 2, 4, 8, 16, what's happening is doubling. So I'm going to go ahead and write that down. We are doubling. So maybe instead of this plus 2, 4, 8, we could say times 2, times 2, times 2. So this will be 32. 8, 9. So go ahead and see what you can come up with. 64. You might want a calculator at this point if you didn't already grab one as you came in, to help you kind of with this doubling. The numbers are going to get pretty big pretty fast. Go ahead, pause the screen, grab a calculator, fill out the rest of the table. I'll be back with the answers in just a minute. So as you can see from this pattern, just following the doubling, and again, I helped use the calculator to help verify what I was doing. Just times the number by 2 as I came out. Numbers get really big really fast. And in a year, we have 8,192 rabbits. Anybody want to tell me what my fourth assumption is? 1, we already said that the original rabbits keep producing. Everybody, it doesn't matter who they're mating with. We always get a male and a female. And no rabbits ever die. That's the fourth assumption. No rabbits die. And within a year, that's probably pretty reasonable. But that's the idea. We have done that. So we have a pattern of growth. We have a diagram. We have rabbits. Have we done anything about describing our pattern of growth? Doubling is the word I used, or timesing by 2. I always also like to look at add the number I have. So by adding the total, I mean what we were seeing here when I had adding, that I add 2, then I add 4, then I add 8, then I add 16, then I add 32, then I add 64, and so on, which is really just doubling. I want to see if that made sense. I like, as far as how does it compare to growth patterns that I've investigated previously, it is, the pattern is consistent. I multiply by the same number every time. In linear patterns, So this is more of a different thing. I was adding the same number. Now I'm multiplying by the same number, so that's a difference. But both patterns were consistent. So the difference is between multiplying and adding. There was a starting place in both terms. My starting value occurred at an input of 0. So let's write that one down. Which, by the way, if we were to graph this, does it ask for a graph? Diagram, table, no. If we were to graph it, we would be, I'm not sure what my point was. Oh, that would be the y-intercept. I think that's pretty good for now. So that's our homework. We'll get into homework, and so if you watch the next video, there'll be some hints on how to do your homework. Have a great time.